Precalculus, how you doing? 7 o'clock. It is 7 o'clock on Sunday, and hopefully you're preparing maybe a little bit for the test. No, we have already done part one. Have not graded part one yet. We'll grade all of those together, so we will get that done. Also remember, hopefully you got that remind message. We are moving the test part two to Tuesday. The reason for moving it to Tuesday is because we have a special guest that was going to come in on Tuesday, but for other reasons is unable to come, and I really want you to meet him. And so because of that, we're to him come in tomorrow, and I think it'll really be impactful for y'all. At this time, please in questions. Away again, text a question if for some reason I'm on a question and you're still struggling. Please make sure you so again we can do that and then go from there. Also, today's sponsored by Gatorade. Every time I say Gatorade, go Gatorade, right? Go Gatorade. All right. Let's get away. I don't see any viewers yet, but necessarily mean there's no viewers. It very well could be that you're listening at home. So let's do this. Let's get this up and running. Let me get at this. I pretty much have an idea of some of the problems that might be might be a problem to you. And so what we're going to do is we're going to kind of show you this here, and then we'll go from there. All right, actually, get this squared away here. Screen share. Sweet. All right. All righty. So as I think through some of the problems that we might struggle on, I kind of had a pretty good idea of maybe some of the ones that maybe people were up and down on and that sort of thing. I know a couple of the vector ones and that sort of thing were ones that maybe were a struggle. And so we'll deal with those and address those right now. I think if you remember, if you go to kind of the back page, and I'm actually going to pull up the review here myself. Pre-cal, by the way, while that's going on, we also make sure we mention it's the one that says kind of the updated one. I'm actually getting it right now. Solutions unit 4. It should be right there, and it should be at your disposal. If you have questions on that, you can see me, and we'll. All right, let's see here. Let's do this. If you have a question, you can kind of text me the picture. I'm just having a hard time pulling this up right now. I think this one's it, but I'm not 100% sure. So I may be doing some that are, I think this was it. Yeah, here we go. All right. I think I'm on number 12 on the review sheet. So if you're looking at number 12, you can kind of see that there. But number 12 is a one that, man, it's just a good one to kind of know and do. It has multiple parts to it, and so it kind of helps you in determining, what things you know and what things you don't know. First of all, it tells us that W, the vector W equals 3i plus 9j. Remember, I deals with the x where j deals with the y. And then we have vector V equals negative 5i plus 12j. There's a couple things that you'll need to do. Number one, write in component form. Well, remember in component form, we have an I and J, and I just got a text here. JT's with us all the way from LA there. He says, could you do a dot product one? And we're going to definitely do that on number 12 here. We'll go right down that list, and we'll go from there. So this should be in component form 3, 9, and this should be negative 5, 12. All right. So again, those are the two parts that we're looking at for component form, and we've got that underway. The next thing says, you have 3 plus negative 5, which gets me negative 2, and 9 plus 12 gets me 21. So my is negative 221. We just simply add the i's and add the j's together, and then we can put it in component. This form right there. All right, next thing says, what's 2w minus v? Well, just like anything, just like something that's scalable right now, we got Grace on the line. We're going to do numbers 9 and 10 in a little bit too, because Grace is there. We'll find. Right here we have 3i plus 9j. We could kind of put in minus negative 5 plus 12j. Notice I also use component form there too. It's kind of up to you. But just like before, this negative is going to distribute in where it's now 5 plus 5. And this 2, multiply the 2 across to get 6i plus 18j plus 5 minus 12j. So now we add the i's together to get 11i. Should be I. I'm sorry about that. Plus 6j. So if we were to put in as a linear combination, 2w minus v equals 11i plus 6j, or if we wanted a component form, we could say 11 comma 6 with the head and tail to get it to component form there. Thing is d multiply two vectors together. Remember, anytime we're multiplying w times v and they're two vectors, what we've got to do is Lone Wolf, you're exactly right. You definitely put that on online. So I know it's lagging a little bit. I even saw that today, so I apologize for that. So as I put this in right now, the dot product of WV is 3 times 15, okay? Put that there, okay? Because again, 3 times negative 5, negative 15. So we have negative 108. So instead of having two values, like negative 15i plus 108j, when we do the dot product, would end up getting something like 97. So positive 97 would be my value. We actually call this a scalar because we only have one magnitude here. We don't have two, an I and a J, or a component form, and to get us that direction, since we only have value scalar 4. Next thing is this: when we find our magnitude, that's also an important thing to know. Remember, when we find magnitude, the magnitude is the square root of a squared plus b squared. So if I were to do magnitude, it would be square root of 3 squared plus 9 squared. Okay? So I get square root of plus of 117. All right? And I don't think, actually, I think you that 3. We can actually say 3 goes into 117 39 times, and down 3. So 3 root 13 would be the same as square root of 117 for the magnitude. You'll see it in terms of like velocity. It just depends on that. So again, 3 root 13 would be you find that. Last but not least, if I were to find the angle between the two, okay, angle between the two vectors. Remember that the formula is cosine of theta equals the dot product of, in this case, not over its magnitudes. And I kind of shortchanged myself over here. I actually didn't solve for vector b. Negative 5 squared, remember in parentheses, plus 12 squared. When simplified, I get 20. Actually, it's actually 13. So I could plug in 13 there. 108. I know we're lagging, Grace. I apologize. Remember the dot product. To find the dot product of that, you multiply the first two together, which would be 3, 5. I get negative 15. And then I add what the product of the y's are. 97. Okay, 97 there. And so in looking at this, what we've solved for cosine of theta over each of its magnitudes. Well, we've already done that. We know 13 is v and w would be 3 root 13. So for me, I like to multiply that bottom out first to where we have 13 times 3 root 13 times, yeah, here we go. Perfect. 100. But then if I take 97 and divide by that, okay, so if I put in my calculator 97, so this whole thing is 0.6898, and it keeps going on and on. But I'm going to keep my calculator one more time because cosine inverse is in order to get theta by itself. So let's find the cosine inverse of that answer. If we round to the nearest degree, we can just say the angle between the two vectors would be 46 degrees there, okay? I have some questions on that. So if you end up doing that, in fact, what I'll do is I'll keep that forward, all right? Awesome. All right, I think what happened was, I think Grace said, yeah, 9 and 10. Okay, good one. 9 and 10, 9 states, find a unit vector. 3, negative 2. Okay, so 3, negative 2 puts it in component form. Find one unit. I'm going in the same. That's awful line. There we go. Okay, let's pretend that. Well, let's pretend grow taller. So he was going to grow in this direction. Okay, no comments, please. No text messages or anything like that. Okay. So let's say he was growing taller and he was going as a vector. But then all of a sudden he states, you know what? Instead of growing 10 inches this next year, which who knows what might happen. Negative 2, but let's say I want to find the same vector, but this time I only want this to be 1 inch or 1 unit long. Well, we could take the same vector, try to find something in the same direction, and find out what that vector is with only 1 unit long. Okay, so to do that, we actually say, and a lot of times you'll see this, equals the vector over its magnitude. Meaning, that right there means that we're trying to get a vector that take the vector 3, negative 2, put it in the top, divide it by its magnitude, we should be fine. Is equal to the square 3 squared plus negative 2 squared. Make sure you put parentheses. 9 plus 4 magnitude is. Well, there's a problem, right? Because once I do that, I can divvy up square root of 13 over root 13, or put that in there. If rationalized, we get 3 root 13 over 13. And this vector, it would have the same direction, except the magnitude, if we were to do a squared plus, or square root of a squared plus b squared, it would equal a length of 1. And so that's why we call it, what is a vector with 1 unit length? That's what we're talking about when we're discussing that there. All right. let's see here. Number 9, number 10. All right. Find an angle between the two vectors. We did this one earlier. So if you want to try it out here, and then get back to me. And then you can always pause it, come back, see if you got it right. And by the way, as I do number 10, if for some reason you have a question, throw it down there, and we'll do it in just a second. All right. Remember that all of these formulas you will have on the test come Tuesday. All right. You have all the formulas there. Same thing. Notice too that this right here is the formula where we're trying to find the angle between two vectors. So let's look at a picture. If we were doing right, and then the other one would be -3, 8. So it'd be kind of up in here, up in here. Y'all gonna make me lose my mind. I know you get a concert today. That's all right. It's okay. We're all good. All right. So theta would be the angle that falls between. If we look at this specific one, remember the dot product is the first two multiplied together. -2 times 8. I'll put those together there. Remember this. This on the bottom, we're trying to find the magnitude of each. So we'll take the square root of 3 squared plus the square root of -3 squared plus 8 squared. And that's how we find that magnitude. So we have 9 plus 4, which would be the square root of, and 9 plus 64, which would be the square root of 73. So what we're going to do is we're going to have 73 multiply this by the square. Simplifying the top, I get -9 plus -16, or negative over. Beforehand, I like to simplify this. So I'm going to put in my calculator the square root of 73 times the square root of 13. So 3 square root of 13, and we'll get 30.80 and so on and so forth. -7, -27. Let me go back here. Divided by what my answer was. Okay. Sorry, I'm a little slow. Like negative, something around there. So before I do that, remember, I'm going to take the inverse of both. Get it all by itself. Get theta by itself. When we do that, I got 151.21 degree to get 151 degrees. And remember, that is, in context, that is the angle that falls between the two vectors of U. All right? All right. Hey, great questions right now. Loving it. Absolutely loving it. I think is correct with that. It is kind of lagging there. I apologize for that. If you have other questions, throw it out there. I know some other people may have more questions there, but I do see one on number 8. In fact, I'm just going to do one that's one where I say, let's say not even U and V, but let's say I've got a point that's 3, 2. And say this is my initial point and this is my terminal point. What that means is that you have a start point, 7, and I have an ending point. So from my initial to my terminal, what is that vector in terms of I and j? Well, remember that in order to find it, we do x2, not squared, I'm sorry, let me put 2 down here, x2 minus x1, and then we find y2 minus y1. Well, remember, x2 would be the the initial, which is 3, right? And for y2, we get 7 minus y1, which should be 2. My second, because that's where it's traveling to, right? So now I get negative 5, comma 5. So you could do different ways. Negative 5j would be sufficient. Name the vector v, that's perfect. Or you could say negative 5, comma to your mama, that's fine. As long as you put it down there, you're good to go. You're G to G, all right? Have I said? Good stuff. All right. More questions? More questions out here? I could just keep going, I guess, you know? Keep going. I guess I could do the boat pier problem. I should do the 4. Oh, yeah. Well, the boat pier problem, we kind of already did law of sines and cosines. I guess I could do the number. Man, slot. Good stuff. All right. Those of you over in Sweden, text me. Thank you so much for showing up. Good to have you here today, and I appreciate you showing up and supporting. All right. Now, remember, let's just pulling on one object. Let's pretend that we have. We'll pretend that we. No, we're not stealing. I'm sorry. Let's say we're trying to think. Let's pretend this is just a weight. How about that? So I don't get in trouble online here. Weight 1 is over on this side right here. Okay, and let's say person 2 is on this side. Say Grace is over here. Now, as they both pull on this, remember that we have something going on. First of all, in order to have a vector pounds, and we have direction, 40 degrees and 120 degrees. Now, in order to solve this first one is addressed when we go 40 degrees. So I'm going to go 40 degrees. Pounds, all right? Because again, they're both pulling this. Maybe they're taking the weight from, west. And let's pretend that the next one, well, at least not pretend, but it tells us that it's 120 degrees, which makes the angle that we're looking at. It's absolutely fine. Just make sure you kind of note that and make sure you know what you're. Magnitude would be 100. What is the resultant force when Grace plus JT? What's really happening with this weight, right? Where's it going? Well, since they're kind of acting upon each other, their force should be greater than what they could individually do. Now, towards that same north angle, we should have a higher degree of force created from that. But just what their vector is in terms of I and J. Well, remember, let's take Grace's side. We know that this is 40 pounds. We're trying to find the opposite and the adjacent side. Well, if we know the hypotenuse, we know exactly that we're going to go to sine of 40 equals the opposite over the hypotenuse. Well, if I were to multiply by 90 on either side, I would get my opposite is equal to 90 sine 40. Well, you guessed it. With the adjacent side, we would do 90 cosine of 40 to find what that adjacent side was. So for Grace's, let's find it here. When you're done putting in your calculator, I want you to yell at the screen, okay? All right? Just yell at the screen. If for some reason your parents are looking at you or whoever's there looks at you weird, it's worth it. It's completely worth it. So yell at the screen when you have it. JT, I hear you yelling at the screen. Nicely done. You're exactly right. The sine would be 57.85. We'll round to the nearest hundredth. Is perfect. And the cosine would be 68.94. Well, since cosine's to the right and to the left, we know that will be I, whereas the sine is going to be J because that's opposite there. Both will be positive because it will go to the right and up. Well, the same pattern follows with JT's over here. Notice that some people use the cosine while 120 because, again, it'll follow the same pattern. 120 is right here. Sine 120. And let's do the cosine as well. And you kind of, once you get in the rhythm here, you kind of start getting the pattern with how to solve for, maybe even to kind of go from there. Now, the reason why I like the 120 degrees, that is, and not 60 degrees, is our sine. So if you use 60, it would just be positive 60, but use negative. It goes to the left. So that's negative 60i. And the J should be 103. Again, when I use this now, I've got JT's force and I've got Grace's force here. I did both Grace's and JT's together to get what we call our resultant force. Add that to 103.92, getting us 161.77. All right, so that's 0.77 J, positive. Now be careful on this one because one's positive, one's negative. 68.94 minus 60 be 8.94, and we'll just say 8.94 I plus 161.77 J is our vector there. Now, a couple things to note on this. First thing is that it asks us first to draw the graphs of the two vectors. That's what we did over here, right? We did that right here. The next thing it states is to find it in terms of I and J. We did that right here. The third says find the resultant force. That's what this is, okay? And then our final component is to find out what the direction and magnitude is. Now, this is our final thing, and it's not too difficult. But if you look up here, I'll kind of make it into a different color. One thing to really note is that my resultant force goes 8.94 to the right and 161.77 to where it's really shooting up there, right there. But remember, we still have triangle. So the things that we're trying to find are x, which would be our magnitude here. Well, we know that 8.94 is our x. Outside. So to find out what the angle is, we're going to say tangent of theta equals 161.77. Well, what can I do? Yell at the screen. Very good. So tan inverse of 161.77 divided by 8.94. Make sure you get the correct sign. 86.83. Okay? And so that happening is this weight will be going a little higher than 40 degrees. It should be headed in this direction, up. Will go. All right. Next, we're going to find the magnitude. We find the magnitude by doing the of 8 squared plus 161.77 squared. We're going to square root both sides. Let's see here. Square root. There we go. The answer. And when I do, I get 160 is my magnitude, or you could put pounds here because that's our new force for our magnitude right there. So we have our magnitude, which is this right here. This is the pounds of force that's created in our direction. So if I was looking here, this would be 162.02 pounds of force is one weight or one head or whatever it may be in that case. All right. So again, it's what we're at when we're solving there. All right. All righty. Hey, are there any other questions out there? Making sure if there's questions out there, we could touch base on it. I'm looking also at Remind 101. So if there's anything out there, I know some people are chatting it up there. Grace has got some really good questions there. I think I did most of them. Some of you may also need some more time, maybe come on in for some help. I know it's been only about a 30-minute session. One thing with the bonus that might be worth your time here, while I'm got some extra time and I'm waiting for responses, is you know. All right, actually, I'll just do this. Plane flying at 340 miles per hour at is 120 degrees, 210. Okay, this is where the plane is going. Okay, it's a plane. Okay. So if it's from the west, I'll show you how we look at that here. But what is two things? We just like we did before equals ground speed. Okay, so I'm going to get you started on this one, but so at 210 degrees, put that around here, 210. You know okay, so just like before, we'll do 340 cosine of 210. Remember my J is, and the cosine is my I. All right, so this will be my force when I find this one. 50 miles per hour, sorry, 50 miles per hour from the west. So if it's coming from the west, that means the vector should look like this, to where it goes straight to the right and goes 50 mph. Well, if that goes straight 50 to the right, what we're saying is that 50 I is plus 0j, because it doesn't go up and down, no direction there. But that's the vector for, let's say, W. I can add these two together, and just like last time, I can find what the direction is by doing tan inverse. So I'm making what the square root of a squared plus b squared is, and what it occurs at or from. I helped you there. If you check out number 13, I actually just did it before this plane problem here. And continue with this and end on this note here, and then we'll go from there. So we have 340 sine, 340 cosine. So this one should be, up here should be negative 294. And this one should be negative 170, sorry, negative 170J. Perfect. So when these two together, I should get my graph 45I minus 1A. So this is the, I remember, like, if you think about it, when you go over to Europe or whatever, sometimes there's wind or like current in the pattern where your plane isn't slowing down. The wind affects the plane to where it could help or even hinder the plane, depending on what was going there, all right? And I think the pad just all right, so once I add those together, this is what my new vector is, right? You could name it U, V, whatever. So to find it, remember 170 over negative 244, right? Right, what we could do in that tan inverse, whatever that angle is, it doesn't matter because when we do it as something positive, tan inverse, this might be a good one to just kind of go over. 170 divided by 244.45, which is 34 degrees, but remember, that's just this angle right here because tan inverse can't solve quadrant. So remember, it's only what this is. So 34 plus 180 gets me 214 degrees. And then remember, when we solve for what the magnitude is, magnitude of u, we can square root of a squared plus b squared to find that, which would be negative 244.45 squared plus negative 170 squared. And we take the square root of that, and then that's how we find that there. And that's how we would do it on that one. So I'll keep following through on this. If you have another question, let me know. But right now, I'm just trying to throw this in my calculator here. Let's see what we get. I'm in the process of square rooting it, and I got 297.75 as my magnitude for what the plane is currently having on what we call ground speed there. All right? All righty. Any other questions? I don't think so. If you have any other questions, come on in tomorrow morning or even Tuesday morning. We'll get that on. Remember, test is Tuesday. Love you all a lot. Anything else I can do, please let me know. Yeah, possibly can. And in doing that, if there's anything I can do to be a help, please let me know. See y'all.